The thing about using translate is that it moves our registration point, it moves our center point, and that's the point at which all of our objects are then drawn from. So looking at the solar file, you'll notice that every planet or moon is an ellipse, and they all are drawn at 0, 0. So their x and y coordinate for each one that is drawn is 0, 0. So instead of drawing them at specific x, y coordinates on our global coordinate system, the main document or screen coordinate system, we're translating their coordinate system so that we're kind of resetting it to start drawing from a new point. That's what translate allows us to do. And if we want to use translate in, or use rotation, it really does work well to use translate to accomplish that, so that we can have objects animating around a central point. Now we could have, instead of using translate, we could use sine and cosine and effectively convert our document to a polar coordinate system, and we could perform all of these same movements and animations, but it would require some trigonometry on our part to do so. Instead, we're just saying rotate, and as we're rotating around a specific point. So looking at this, we can see that the first thing we do is translate to the center of the document and then draw an ellipse, and it's drawn and filled with the color yellow, as that's our sun in the middle. So we translate to the middle and then draw an ellipse at 0, 0, because 0, 0 without that first translate is going to then be the top left corner. So if we comment that out and look at it, you'll see that now everything starts as we would suspect, with 0, 0 being in the top left corner. So all translate does is take that starting point at which everything is drawn from or rotated from and moves it to a new location. That's all translate's doing. It's just moving that registration point. So if we go to the middle, then we can just draw from the middle. So that's the first thing that's at work here. The second is that we're taking advantage of something called push and pop. So anytime we do a translation, we're able to save that translate information in a transformation matrix. And we're able to undo that translation. So if we do it within the, so pushMatrix, popMatrix, what they really are saying, I want to start a transformation and then I want to end the transformation and pretend like I never did that translate. So I say pushMatrix, I rotate, translate, do whatever I want to do, and then I say popMatrix, which then ends that translation so that I'm able to then do it again and translate to a new location. So using push and pop on the matrix allows you to modify individual objects without affecting objects that come afterward. Otherwise, that translate or rotate becomes a cumulative effect. So that if I say translate, then say translate again, and translate again, and translate again, each one of those are translating from that initial starting point, and unless I use push and pop matrix, I never reset it until I get back to the beginning of my draw loop and start over. So that's the kind of magic of what's at work there. So right now I have a document that is drawing 4 rectangles on top of each other. So if I start out the first one at 0, 0, now I'm going to say translate, and we're going to move this one over 50, 50. And if we repeat that, just throw some indents in. We don't need them, but just to kind of show what's really going to be happening here. So I'm drawing a rectangle, then I translate my 0, 0 to 50, 50, draw another rectangle at that new location, translate 50, 50. So looking at this, we should see an interesting pattern emerge on screen. So you will see that each one of these rectangles was drawn at 0, 0. But I've translated what 0 means. So that 0, 0 point, that origin point, which typically is the top left corner of your screen or of your document, we've now made that mean something different. That's all that translate does, is it makes that point mean something different. And that's the tricky part to deal with. So when you're dealing with the rectangles, it's not so bad. But when you try and do the same thing and you start dealing with circles and moving or rotating in a circular direction like the solar system, suddenly this gets a little bit wonky. So that's just something to keep in mind as part of it. There. Translate is cumulative. Thus, I translated 50, drew another rectangle, translated 50, drew another rectangle, translated 50, drew another rectangle, and we can see, so that became cumulative. So the final rectangle, instead of being at 0, then 50, then 100, it now sets 0, 0 at 150 right here. So this is 150 by 150. That's essentially what X and Y is. So I could have not used translate on any of these lines here, and then coded each rectangle to be at 0, 0. And then the next rectangle would be drawn at 50, 50. The next rectangle would be drawn at 100, 100. The next one at 150, 150. That would give me the same identical visual result. So for placement of artwork on screen, using translate isn't, that it's not that useful, because we normally are thinking about an object within the whole document space and what that X and Y is. But when it comes to wanting to be able to rotate an object, if we don't use translate, we get some really weird things occurring. So we're going to add a rotate to this document and see what happens with that. So I'm going to set up my angle theta. We'll start it at 0. I'm going to start putting some rotate commands in here, and this is where things are going to get really messy. So we'll rotate theta and then make theta increase itself. Just a little bit each time. So it's a very slow increase in theta. So what we're doing is we're rotating in radians. So we rotate 0.01 radians, 0.02 radians, 0.03 radians, and we'll get to watch the whole document spin into oblivion very quickly here. So we'll see, and if we wait, it will come back around, because they're spinning around that original origin point. So all of the items are rotating around that point. So this is where we need to be able to translate that, because if I wanted to have these objects not rotating around the top left corner of the screen, but rotating around around their center points, then if I translate what that point is, it works out much better. So right now we're rotating. So if I issue a rotate command, it will rotate around that top left corner, the original 0, 0. But if we now move this down a line, So it's below the first translate here. And watch. Well, now see they're rotating around that new origin point. So I said translate to 50-50, so it's rotating around that point. If we go to the next one, so we can see where they're rotating around. It does create an interesting pattern, especially if we don't clear the background each time. So using this as a means to draw is kind of cool. So I'm going to put it after the final translate. So we'll see it's only now rotating that final object because that's the only thing being drawn after it. But the challenge that I'm going to issue to you right now is by changing one line of code, I want this fourth box to rotate around its middle instead of its corner. So change one line of code only. You don't have to add any more lines. You don't have to move. But we need to change one line of code so that this box, instead of rotating around its corner, spins in place around its center. That's my challenge to you right now. How do we do that? So I want this final box to rotate not around its corner, but around its middle. So we only have to change one line. So when working with our translate, all we're doing is repositioning our 0, and then we can draw objects in relation to that 0, and we do not have to draw objects in positive values. We can do them negative. Going back to the solar system. Now, one thing about the solar system here, as I was putting this one together, I ran into an interesting issue. So when I was reversing the rotation, I'll just get rid of that. I'm going to rotate one planet one way. Oh, no, this isn't the fully broken version yet. But with, this isn't the fully broken version because it's using push and pop, which we'll go into in just a moment. But if we look at if they're both rotating theta, so now my planets are going in the same direction, so luckily now there will be no planetary collisions where one planet hits the other planet's moon. So that's good. But it's more fun when we have to worry about cosmic destruction and wonder when that's going to happen inside the project. So this now is going to move the conversation into the push and pop matrix, but we'll go back to our basic translate that we have going here. So with this, by changing it to a negative value, it was able to reset it. Now, I'm going to even start out and just say translate. And the translate I want to go to is my width divided by 2, height divided by 2. And we're not doing z. Translate does support the third dimension, x, y, and z, but that does require you to set your sketch up for 3D. So you have to set it up for working in 3 dimensions. And if you read then the chapter in your book, chapter 14, that talks about it, talks about doing 3D, and just like we have ellipses and rectangles, we have spheres and cubes that are available to us, and 3-dimensional polygons that you're able to construct. So you can do some pretty cool things with the 3D on it. but then you have to set it up in your size statement if you're working in 3D, where you'd go height, width, and then you specify that you're doing it in 3D. It assumes you're doing 2D unless you say otherwise. Otherwise, we could say we're doing processing in 2D. So you can do that, and that's totally valid as part of it. But we're not going to construct 3D elements right now. If you're interested in doing that, the book has some great instructions on it, and online you can find volumes of resources that go into it in much greater detail and depth. We may at some point, but not this morning. I'm just going to leave my standard height and width as part of it. So now if I translate to the middle here, run the sketch. I do recommend when you're working on putting your project together, it's a good idea to set things up, do one line, do a translate, run your sketch, and see what it did. Because if you put in translate and translate and translate and a bunch of draws and a bunch of loops and a bunch of classes and objects and other things, and you have all kinds of crap going on, you have no idea what did what or how it's all coming together. It's quite straightforward, unless you're doing something that needs closure, to, after you do a line of code, run your sketch and see what it did. See what that line added to it. That helps reinforce the learning. As you gain more experience with your coding, you can generate more code before you run it, but it's still a good idea to run it whenever it's feasible to do so, so that you don't start creating errors that compound with other errors and compound with other errors, and pretty soon it's just a complete disaster. And then you're stuck trying to figure out where it broke down. So test often. Run your sketch often to make sure that you haven't coded yourself into a black hole. That's just my little soapbox speech for the morning. So I've translated to the middle here. Now, and drew a rectangle at that point. Now what we can do with push and popMatrix on this, I'm going to have to change some of these translates so they aren't all ending up at the same spot. I'm going to just modify the next one here. So I modified one, and we should see a difference in location. So it's not evenly spaced. It's now closer on the X but not on the Y. But what we can notice here, and we probably should add some fills to the boxes. So I'm just going to put some basic colors in so we can tell the boxes apart. So make the first one red. The next one green. Make my next one blue. And I'll make the final one yellow. Red, green, blue, yellow. Those are my colors. If we look at it, we should see that. Again, test often so that we can see what is happening with your project. So, just a comment so it's easier to see in the code. So now that I can tell which box is which, if I use a pushMatrix, in pushMatrix it's a command, so it has parentheses, but it doesn't take any parameters. I don't say pushMatrix and put something in those parentheses. I just say pushMatrix, and now it remembers this translation, and when I'm done with that translation, I can say popMatrix. So what that does is that now takes this chunk of code, and this translation here of 50/50 will only apply to my green box. And I'll even make it at 150 so it's way out there. So after that, what we can figure out is where is blue going to be. This translate, because it's only happening to this box, I say pushMatrix, remember this translate, popMatrix, stop remembering it. That means I'm back to the middle point. So this translate means my blue box will be 25 left of center and 50 down from center. That's where that box is going to land. So here is center. Now the blue box is 25 and 50. The green box is now out by itself, nice and lonely, because its transformation is now no longer part of the others. Its translation is self-contained. So that's when you use push and pop, it creates a self-contained translation that prevents it from affecting whatever happens afterward. So that's when you have an object and you want the object to move, but you don't want it to affect anything else. That's when we use our push and pop matrix commands.